Good afternoon, everyone, and welcome to today's webinar. My name is Michael Cook, and I'm a Senior Technical Advisor in the Department of Energy's Office of Science. I'm joined today by colleagues from the Office of Science to discuss the funding opportunity announcement, Energy Innovation Hub Program, Research to Enable Next-Generation Batteries and Energy Storage. As folks continue to join us online, I'll run through the logistics for today's meeting. This meeting is being recorded. Closed captioning is available through the Zoom meeting client. We'll begin with a presentation, but have reserved some time for questions as part of today's event. Please drop your questions in the Q&A box so we can write a response or answer them live. Michael Zarkin, Director of the Office of Grants and Contract Support, is joining us to help answer questions during the session. With that, I'd like to introduce Dr. Andy Schwartz from Basic Energy Sciences to discuss this funding opportunity. Dr. Schwartz, I'll hand it over to you for today's presentation.
Great. Thank you very much, Michael. I appreciate that introduction, and thanks to all of you who have joined today to listen in. Good afternoon. I also will briefly introduce a few of my other colleagues who are here with me, Craig Henderson and John Vetrano from the Office of Basic Energy Sciences, as well as Michael Hill, a contracting officer in the DOE Contracting Office overseeing this funding opportunity announcement. So we're here today, as Michael introduced, to talk to you about a recently issued funding opportunity announcement for the DOE Energy Innovation Hub program focused on next generation batteries and energy storage. The funding opportunity number is shown here. This funding opportunity announcement, or FOA, was issued a few weeks ago, January 26th, 2023. There are a couple key deadlines here, which I will remind you of a few times throughout this talk. The first key one is the submission for pre-applications, a requirement of the funding opportunity announcement. Those are due no later than March 9th at 5 p.m. Eastern time. We will then evaluate those pre-applications, and responses will be sent to the applicants no later than April 3rd, 2023. And for those applicants who are encouraged to submit an application, the submission deadline for the applications will be May 18th, 2023 at before midnight, 11:59 p.m. Eastern time. And I'll go through some of the details of the submission process for both pre-applications and applications later in this in this webinar. I will say the disclaimer at the bottom: the presentation here is intended to adhere to and summarize the contents of the funding opportunity announcement, but is not intended to add to, take away from, or contradict any of the requirements. And in the end, what is written in the funding opportunity announcement is the controlling language, and I encourage you to read in detail the funding opportunity announcement. As Michael said, excuse me, we're happy to take questions during my presentation, which should take, I think, approximately 20 minutes, and then we'll have plenty of time for a dialogue and additional questions throughout the hour. So some key elements for this funding opportunity announcement, the so-called Batteries and Energy Storage Hub, FOA. This FOA is soliciting new applications only. So we are looking for to start new activities and new awards in this area. Applicants, a number of different institutions are eligible, all types of domestic entities, including universities and colleges, academic institutions, nonprofit organizations, for-profit organizations, for-profit industries, and DOE national laboratories. Other federal agencies, other than DOE and or their FFRD's federally funded research and development centers, may participate, but only as partners, not as the lead institution. We expect that all applications will involve multidisciplinary research teams. These are large multi-investigator awards across multiple disciplines. Multi-institutional applications are allowed, and to some extent, we expect to see multi-institutional applications, but the application should be a single application submitted on behalf of the lead institution, and that applies to the pre-application as well. The team should have a single pre-application submitted by the lead institution. The FOA also encourages applications that are led by or in partnership with minority-serving institutions, broadly, including historically Black colleges and universities that are underrepresented in the Basic Energy Sciences, or BES, portfolio, and also applications including individuals from groups that are historically underrepresented in STEM. And there's links in the FOA and here to more information about the qualifications, particularly for the minority-serving institutions. So the scope of the FOA is summarized here, and the details are in section 1 of the FOA. I refer you to section 1 for more detailed descriptions. Energy innovation hub scale projects are intended to provide the scientific foundations for new energy storage technologies that are critical to the DOE mission, particularly the mission to provide clean energy sources for both the grid, electrical grid, and transportation from intermittent and stationary renewable sources such as wind, solar, etc. Prioritization will be given to basic scientific research leading to scalable energy storage technologies that could significantly impact decarbonization of the economy and or enable the transformation of the electrical grid to these clean, renewable energy sources. And I'll focus here and emphasize the basic scientific research aspects. This is fundamental science, the Office of Science within Department of Energy and Basic Energy Sciences, through which these awards will be made, is focused on basic science. So really the emphasis here is on basic science to seed and accelerate new next generation technologies beyond today's generation of batteries, which are dominated by lead acid and lithium ion technologies. Again, basic science, you see us repeat this phrase over and over, and I want to make sure that everyone is aware. So while the long-term vision is on impacting energy storage technology, battery technologies, the emphasis on the proposed research is on the fundamental science foundations. Now, the next bullet's important. We also say that basic science is expected to be relevant to next generation technology offices being supported at higher technology development levels by DOE. So this is to say that while the fundamental science is at the low technology readiness level, or TRL, maybe even not on the TRL scale because we're not talking about technology, that doesn't mean that the science can't be impacting higher technology development levels that are actively engaged in by other offices in DOE. So, for example, one could have a work at a higher TRL level where the barrier to moving it forward toward commercialization is a fundamental science question. If those fundamental science questions can be identified and addressed, those fundamental science questions could be relevant to these proposals for this hub FOA. The research that you propose in response to this FOA must align with the so-called priority research directions that were identified in this recent workshop report, Workshop for Next Generation Electrochemical Energy Storage, which was published in 2017. The link, this is a link, and we will put some of these links into the chat as I talk. My colleagues will, so that you can have them directly. These slides, as well as this recorded presentation, will be posted in the near future onto the website where the FOA is posted, and I'll give you a link to that toward the end of the talk. It's also important that the proposed research is consistent with the future technology needs for electrochemical energy storage as defined in the DOE Energy Storage Grand Challenge. Again, linked here, and you can find more information about that Grand Challenge on the DOE website. So as stated before, the majority of the research activities proposed should address the priority research directions identified in this basic research needs workshop report. Up to 3 primary PRDs that are most significantly addressed by the research should be clearly listed on the cover page of the pre-application and the proposal narrative as specified in the FOA. We require that you identify at least one of the PRDs from the report. And if you don't do so, if you don't identify any PRDs, the pre-application or application may be declined without review. FOA also states that applications must build upon and go beyond the accomplishments in the field to date. Broadly speaking, the accomplishments in energy storage research, including those that have been supported by Basic Energy Sciences in the past through our core research programs, through our Energy Frontier Research Centers, and through the JCESR, the Joint Center for Energy Storage Research, the current energy storage hub project that has been active since 2012 and is in its final year of operations. In addition, we encourage the applications to build upon all relevant international efforts. In other words, put your research into the context of what has happened before and what is currently going on in the field. Any award made under this FOA is expected to be highly collaborative with other research efforts in batteries and electrochemical energy storage, including any other award that may be made under this FOA, as well as the broader electrochemical energy storage scientific community. In other words, we want these awards to be interactive and engaged with the broad energy storage research communities. With the goal to advance fundamental research and improve competitiveness of the U.S., the proposed project should energize the wider scientific and technical electrochemical energy storage communities and really serve as national resources, conveners, and leaders. The hubs that are funded through this program are anticipated to be leaders in the field of energy storage research. Moving on to section 2 of the funding opportunity announcement with some of the information about the awards. The estimated funding level for these awards, subject to the availability of future year appropriations, is up to $125 million per year in current and future fiscal year funds. These are anticipated to be 5-year awards, so the total funding is anticipated to be $25 million per year over a 5-year period, again, subject to the availability of congressional appropriations. The FOA states a maximum and minimum award size. DOE anticipates that the award sizes will range from $8 million per year to $15 million per year, though applications may request support in the range from $10 million to $15 million per year. This gives us the flexibility to make awards below this $10 million floor if appropriate, but the limit is $15 million. The maximum, the ceiling is $15 million per year for any application. Given those numbers, and it's anticipated up to 3 awards could be made, though the number of awards, the exact number, will depend on the number of meritorious applications, as well as the availability of appropriated funds. It's anticipated that DOE will award cooperative agreements, national laboratory authorizations, or interagency agreements under this FOA, depending on the nature of the institutions receiving the award. Sorry about that. Okay, some more details. I talked on the first slide about the requirement to have a pre-application. That's stated here again. Pre-applications are required if you are interested in competing for this funding opportunity announcement. There is a limit of 1 pre-application per lead institution. As I stated, for multi-institutional teams, a single pre-application should be submitted by the lead institution, and no institution may submit more than 1 as the lead. Institutions may participate as partners on multiple pre-applications without limit, but may only lead 1. The pre-application must also include a letter of institutional support that must be signed by an official of the lead organization who has authority to commit institutional support for the application. I'll talk a little bit more about that in a subsequent slide. Federal program managers may evaluate some or all of the pre-applications to determine their competitiveness relative to next generation batteries and electrochemical energy storage. Any such review will be conducted by no fewer than 3 federal program managers based on the following 4 criteria. These are stated in the funding opportunity announcement: responsiveness to the objectives and requirements of the FOA, scientific and technical merit, appropriateness of the proposed research approaches, and likelihood of scientific impact. This will be a comparative review, and priority will be given to those pre-applications that are the most scientifically innovative and forward-looking fundamental research, and which we determine to have the highest likelihood of success as an application. The applicants with those highest rated pre-applications will be encouraged to submit applications. Applications that have not been encouraged by DOE will be declined without review. Okay, reminding you of some key dates. I stated these up front, but these are important. The pre-application due date is March 9th. Approximately a month from now. The time for that is 5 p.m. Eastern time, and the pre-applications must be submitted by an authorized institutional official via the DOE Portfolio Analysis and Management System, or PAMS, and all the details about submission into PAMS are included in the funding opportunity announcement. As I stated earlier, we may evaluate those pre-applications for competitiveness, and will provide a response no later than April 3rd, 2023, notifying all pre-applicants of whether or not they are encouraged to submit an application. As stated in the FOA, we expect to limit the number of full applications to approximately 10, with the exact number based on the quality and the number of pre-applications that we receive. Those applicants who are encouraged to submit an application may do so no later than May 18th. 11:59 p.m. Eastern time. And those are submitted through the government-wide grants.gov website, which is linked here. Again, applications that have not been encouraged by DOE will be declined without merit review. We anticipate that the awards will be made during fiscal year 2023, which ends at the end of September. We include here a list of common errors and or things to pay attention to, a checklist for pre-applications. I note that this is not comprehensive list of all FOA requirements. We're just highlighting some of the key elements. And once again, we encourage you to read the details in the funding opportunity announcement to make sure that your pre-application meets all the requirements. Again, basic research, the scope must be basic research that is consistent with the scope described in section 1 of the FOA. We are not soliciting applied research or technology development or deployment. And the pre-applications must address at least 1 and up to 3 of the priority research directions from the 27 basic research needs for next generation electrochemical energy storage workshop. As I stated before, the pre-application must include a letter of institutional support signed by an official of the lead organization who has authority to commit institutional support. For DOE national laboratory applicants, that official should be the laboratory director. For other applicants, the official who signs should be someone with authority over research activities for the entire institution. For example, a vice president for research, a chief technology officer, or an equivalent position. Pre-applications must also include a list of individuals who should not serve as merit reviewers of a subsequent application. There's lots of details of how to craft such a list in this section of the FOA 8.A.10. This is essentially a list of collaborators for all the individuals named on the pre-application, because those collaborators are considered to have a conflict of interest. But again, the details of how to craft this are shown here. A template, an Excel template for putting together this list is available on our website at the link here. And this list should then be converted to a PDF and attached to the pre-application. It does not count toward the pre-page limit for the pre-application, recognizing that these lists can be quite long. Again, the pre-application should be submitted into our PAM system, not via the grants.gov system. And again, instructions on doing that are in the funding opportunity announcement with a due date of March 9th. And I'll note here that late submissions are very rarely accepted. There's some language about late submissions in section 4.f.4 of the FOA, but we strongly encourage you to start the process early and ensure that submissions are put into the system well before the deadline. Moving on to the application stage, again, a checklist, not a comprehensive list of all FOA requirements. It's stated in the FOA that the scope of the work, in other words, the total work effort as measured by the budget to be performed by the lead institution must be greater than that of any other institution involved in the application. Thus, the budget requested at the lead institution must be the largest fraction of the budget. It doesn't have to be the majority, but does have to be the largest budget relative to the other partner institutions. That is our definition of the lead institution. The person indicated to lead, the project director, must be the same as the person who was indicated on the pre-application. And the application must include biographical sketches and lists of current and pending support for each senior key personnel listed in the application. I encourage you to carefully follow the instructions in the FOA on how to put together the biographical sketch and the current and pending support. Compared to past submissions, these are no longer included as attachments to the research narrative, but are attached to the research and related senior key person profile form in the application. And there are additional instructions in section 8A, 9 through 11 of the funding opportunity announcement. That also includes details about what information to include in the biographical sketch and what information to include in the list of current and pending support. And again, as a reminder, the applications are due by May 18th, 11:59 p.m. Eastern time via the grants.gov system, not the PAM system into which the pre-application was submitted. And as with the pre-applications, we strongly encourage you to get the submission into the system well before the deadline to avoid the risk of a late submission, which are rarely accepted by DOE. Okay, finally, before I open it up to questions, and I see we already have some questions in the Q&A, that's great. Where to find more information? The funding opportunity announcement is posted in grants.gov. It is also posted on the Office of Science website, listed here under funding opportunities. This webinar, which is being recorded, as well as the slides, will be posted at the same link here, along with the funding opportunity announcement, within the next few days or by early next week, I believe. Any questions about this funding opportunity announcement that aren't answered today or that come up after this webinar need to be submitted via the FedConnect portal, www.fedconnect.net. If you register in FedConnect and respond as an interested party, that allows you to submit questions that you have and get them answered. It also allows you to see any other questions and answers that have been submitted into the system. So this essentially becomes a kind of FAQ for the funding opportunity announcement. And all questions related to the funding opportunity announcement must go through this FedConnect system. With that, this is my final slide. I encourage you, if you have questions today, we have, as I said, the remainder of our hour to have a conversation and answer some of your questions, either in text or orally. Please use the Zoom Q&A window. You should see it at the bottom or somewhere on your Zoom window. If you open it up, you can submit questions. And as those questions are answered, you'll also see the questions and answers from others. And again, if your question is not answered today, if we don't get to it, or if you come up with additional questions, as you work toward the pre-application and potentially application submission, please go ahead and submit those into fedconnect.net. And with that, I will stop, take a breath, and turn it back over to Michael, who is going to moderate our Q&A session.
Thank you very much, Andy. So we'll be keeping an eye on the Q&A box. A few questions have already been answered while you were speaking by text. But we'll be happy to continue answering questions there and also answer some live. One of the first questions I think you might be able to help expand on, though it was answered in the text and chat, about multi-institutional applications and whether single entity applications are acceptable for this FOA.
Yes, is the short answer. Single entity applications are allowable for this FOA. So if you believe that you have all the capabilities and expertise to at your institution, that is allowable and acceptable for this funding opportunity announcement.
All right. Our next question is about the scope of the FOA. So lithium-ion batteries are out of scope for this FOA, but does it apply to other lithium batteries such as lithium sulfur, lithium air, or lithium solid-state batteries?
Well, I'll start that answer, and I may then turn it over to one of my colleagues to elaborate. Yes, I believe that other lithium technologies beyond the commercial lithium-ion technologies would be, or science relevant to the other lithium technologies would be could be responsive to this funding opportunity announcement. Really, this is meant to drive the science that will provide the foundation for future technologies beyond current lithium-ion technologies. Craig, do you want to add anything to that?
Yeah, just to follow along, the FOA does discuss that there's a need for transformative technologies and then the foundational science to support those transformative. So I think that the standard you should consider is whether the system you're looking at is just a drop-in replacement for current commercial technologies, or really addresses the need for that transformational battery systems that provide different functionality, allow for different things, especially things like long duration storage on the grid. So to the extent that a chemistry looks like lithium and the fact that it has lithium in it doesn't exclude it. You should pay attention to, is it likely to be transformative and result in the kinds of battery systems we need for the future, rather than just replace lithium as a drop-in replacement.
Thanks, Craig.
All right, we have another question to help understand the pre-application review process in particular. Could you go into a little more detail on what is considered during the pre-application review process?
So I would say that we look, so you can read the funding opportunity announcement, which has more detail than I gave on what is expected in a pre-application, and I would follow that. And then as I pointed out, we have 4 criteria that we look to when we're reviewing pre-applications. We look to the responsiveness, the objectives. Some of these questions we've already been addressing. Are these innovative, forward-looking basic science that is likely to be provide transformative understanding for energy storage technologies? We look at the scientific and technical merit, the strength of the science, and the approaches that are proposed. And then we look at the impact and the likelihood of impact and make an assessment. And again, it's comparative. We're looking at them relative to the other submissions that we have received, that we will receive in the pre-applications. So I think the key is to look to the funding opportunity announcement, look to what's described in the scope section, section 1, and the details of what is expected to be in a pre-application. I did notice there was one question, which I think Mike answered in text, about whether there is a template. We don't provide a formal template, but there are descriptions in the funding opportunity announcement about what we expect and is looked for in a pre-application. And I encourage you to make sure that your pre-application clearly addresses all of the elements that are contained there.
All right, thank you. So I'll go down the list. A few other questions have come in. One is there a preference between vehicle battery science and long duration battery science?
Both are within the scope of the FOA. So there's not a particular preference. We are looking for research that has the possibility to impact either or both of those areas. So there's no particular preference given for one over the other.
And I think this one, Mike Zarkin just answered by text, but it could be worth mentioning. How will you evaluate workforce development, DEIA, Environmental Justice 40 during the review process?
So there's a lot built into that. So I'll answer maybe part of that. So all of our funding opportunity announcements from Office of Science, including this one, now have a requirement, not at the pre-application stage, but the application, to include what we call a peer plan, PIER, promoting inclusive, equitable research. I hope I got that right, the acronym PIER. So you must include this peer plan, and there's again guidance in the funding opportunity announcement that gives you guidance on what to include in this, and in addition, evaluation of that peer plan is part of our external merit review. So we will look at that, and we will also ask the merit reviewers to look at that and evaluate the strength and efficacy of those plans for inclusive, equitable research environment. So that answers, I think, part of your question. And in general, we will look at all of those factors in making doing our assessment, in addition to the scientific and technical merits of the proposed application.
All right, I'm keeping an eye on the questions list. Remember, you can put your questions into the pod and we'll keep an eye out, try to answer them both live and by text. One question is about how HBCUs can participate and whether they can be the lead organization.
So absolutely, 100% yes. As I said, all domestic entities, including academic institutions, non-profit, for-profit, and DOE national laboratories can participate as the lead or as a partner institution. So HBCUs absolutely are eligible to participate either in a leading role or as a partner with other institutions. And so I encourage you to look for those opportunities to partner or look for opportunities to lead in partnership with other organizations.
So a couple questions on the scope of the FOA. First, is capacitor or supercapacitor work allowed in the scope of this FOA?
So I'm gonna kick this one over to Craig to answer, to make sure I don't get it wrong.
Okay, so the simple answer to this is the FOA solicits research on the conversion of electricity to chemical bond storage or chemical storage of energy. So if the supercapacitor or capacitor that you're thinking about simply stores the energy in an electric field, then that would not be what's intended in this FOA. But solutions that in some way convert the electricity to chemical storage, then they are intended in this FOA. And remember again that the FOA is targeting technologies that will have a significant impact on decarbonization. So that typically favors chemical storage rather than electric field storage.
And another question on the scope of the FOA, would a furthering of lead acid technology be acceptable for this program?
So I think that it's without seeing the details, it's hard to say. Again, it needs to be forward-looking and innovative. If it's just an incremental improvement on a current technology, it would likely not, at least not be strongly competitive and maybe not responsive to this program. If you have an idea of a transformative advance that in that space, potentially, but it's hard to make the final judgment without seeing details. Craig, do you want to add anything to that?
Yeah, that would be my answer, is that, again, going back to the same parallel to the lithium sulfur, lithium metal answer, it has to be transformative, it has to be scalable, it has to affect decarbonization, and it has to be what you would consider next generation, opening up new possibilities of how energy storage can be used to decarbonize the economy.
Thank you. So next question, will you be creating a teaming list for potential partnering?
So we have not created a teaming list. So the simple answer is no. We encourage the community to look for those opportunities for partnering, but we have not created any specific teaming lists that can be used for partnering.
And is there a preference to include non-R1 universities as members of the team?
So non-R1 universities are certainly eligible as part of the team, or in principle, even as a lead. Again, all academic institutions and domestic academic institutions are. I would not say that there's a particular preference given. But we are certainly broadly across the Office of Science supportive of expanding research to institutions and individuals who have historically been underrepresented in our program. So to the extent you're talking about an institution that meets that the language in the FOA encourages inclusion of such institutions, I would say.
All right, so back to some scope questions. Can a proposal team address multiple chemistries in parallel, such as solid-state battery and zinc-ion aqueous batteries?
So I would the short answer is yes. I mean, these are relatively large projects and can have multiple topics and thrusts, themes within them. We are looking for an integrated whole, so there has to be some connectivity and some connection some cohesivity to the whole project. So you need to make sure that the pieces fit together well in a way that makes sense, fit together scientifically. But to the extent you can do that, yes, absolutely, you can include multiple chemistries. Craig, do you want to add anything to that?
Yeah, simply just to remind you that this is fundamental research, and to pigeonhole your activities into certain technologies might make it appear that it's more applied than fundamental. So again, fundamental basic research. It can cover multiple technologies, but
our next question, is there an additional requirement for energy density in addition to the long duration?
No, we don't have specific metrics or targets for particular technology metrics within this FOA because, again, it is fundamental research, right? So from the perspective of the FOA, we are not targeting certain energy densities or certain durations, though, again, what we're looking for is the science that could, and we hope will, eventually enable those transformative improvements in technology capabilities.
Our next question, could you clarify whether a production and manufacturing process innovation could be considered as a fundamental research?
I can try, though it's hard again with not so much detail. So that's a tricky one. Yes, there is basic research that impacts manufacturing and processing, and one could potentially envision a proposal to do that fundamental science. But I think the key is that you really have to identify what are the basic science knowledge gaps that are limiting that production or manufacturing capability, and focus your efforts on those identified knowledge gaps. Again, with the goal of really making transformative, enabling future transformative improvements in the technology, not incremental improvements.
So our next question, can machine learning solutions be applicable for the priority research challenges mentioned in the FOA?
I would have to say yes. Again, I think if you have some innovative ideas using artificial intelligence, machine learning, or whatever techniques or combinations of techniques to address these challenging problems, absolutely. So I think broadly speaking, theory, synthesis, computation, artificial intelligence, machine learning, these are all the tools of science. And what you need to think about is how to put those together in a way that is most effectively going to achieve your scientific goals that you've set out in the application.
So just a reminder to anyone who's connected, you can open the Q&A box and add any questions you're interested in having answered, either written or live, with Andy and others connected here today, and we'll try to respond to what we can. Our next question, would applications of energy storage technologies to electricity grids, for example, for resilience evaluation and grid decarbonization, be acceptable in this program?
So yes, as we described earlier, we are looking for basic research that is relevant to both the grid and to transportation. But again, we're not looking, the question started with the word applications. We're not looking for the applications, we're looking for the basic research that's going to enable those future applications. So as long as what you're asking about is basic science that could enable transformations to decarbonize the electricity grid, then yes.
And perhaps somewhat related, is any TRL level preferred for this FOA?
Yes, okay, good question. I'll try to do my best with this. So TRL, as probably most of you know, technology readiness level, is a phrase that's used in various contexts about where a technology stands compared to final commercialization. Because this is focused on basic research, basic science, we typically don't talk in terms of TRL levels. That's not what we're doing. We're not doing technology readiness. We're doing the basic science. And as I tried to point out on one of the slides, that means that actually the basic science could potentially have impact at various TRL levels. I mean, the simple way to think of it is that this is the start, and then when it moves into technology, applied research and technology development, it goes on to the TRL scale. But you could have a work that's going on at a higher TRL level that's being impeded by some scientific knowledge gap at some upper TRL level. If you can identify that and then focus your efforts on the science to fill that gap and move that, potentially move that technology forward, you could, have fundamental science that's relevant at higher technology readiness levels. But in general, again, we're not doing technology development or deployment here. We're doing basic science. So we don't tend to talk in terms of the technology readiness level that is appropriate. And that technology readiness level is not mentioned no technology readiness levels are mentioned in the funding opportunity announcement.
All right, looking down our list of questions, one is battery science that could be built from domestic resources preferred?
So supply chains are obviously important and for technology development and for commercialization. Really what we're focused on here is the basic science. Now I do think it's not directly tied to potential future supply chain and sources of resources. That said, I think there are challenges and scientific ones around materials criticality, and criticality can be the result of various factors. And so to the extent you're doing research, you can propose research that could alleviate the criticality issues, potential criticality issues for technologies going forward, then I think that could be relevant to a relevant element of a proposal to this funding opportunity announcement.
Another question, will you accept a current technology that introduces new components to multiply the output of the technology?
So again, it's a short question. As written, I think I have to say, no, we're not talking about technology development here, right? So this is basic science. So as written, I think the question is, the answer to the question is likely no, but again, without more details, it's difficult. I should remind people too, if my answers are a little short and you're not getting what you want, I apologize, but you're always willing to submit a longer, more detailed question through the FedConnect portal if you feel you need to, or if that would be valuable, and we'll try to provide more extensive answers to the extent we can through that mechanism.
And another question about scope. Are algorithmic innovations that would enable faster charging in conjunction with battery chemistry enhancement, would that be within scope?
Okay, I'm going to struggle with this one. Craig may be able to bail me out a little bit. I think that some combination of the algorithms with the chemistry, basic energy sciences emphasizes material sciences and chemistry. That's the focus of our mission space, and so the research that we are generally supporting is in those spaces, not in algorithmic development. That said, if there's an element of the proposal that is algorithmic, there might be a way to include that as a component of a proposal. Craig, do you want to add anything to that?
Yeah, the answer to this question, plus I think the last one, which one could envision maybe components being like a battery management system or some sort of charging algorithm. All those things might be associated with the battery chemistry, and there may be a tendency to want to include them. But again, the fundamental nature of the research shouldn't allow you to go into what is essentially technology development or application-specific research. So to the extent that those things need to be looked at a fundamental standpoint, sure, but again, this is fundamental science, not technology development, and those kinds of things oftentimes are part of systems engineering.
All right, thank you. I'm trying to keep an eye on other questions as they come in. One about the members that can be part of a team. You touched on this a bit, but can national labs other than the DOEs be part of a team?
The answer is yes, but only as a partner member, not as the lead institution. So other federal agencies or the FFRDCs of those agencies are eligible to participate as partners, but not as the lead institution.
So just as a reminder, as we wait for any final questions to come in, that the recording will be available online, and there's more information, of course, available, and more questions can be answered through FedConnect. So one of the questions that came in is research on a quantum battery that utilizes quantum systems to enhance battery performance. considered too fundamental and not favored for this FOA?
So I would say that I don't think that too fundamental is a concern. There's nothing we are looking for fundamental science. With that level of detail, I can't comment on the specific details, but but if you have ideas about how to use quantum mechanics or quantum information science in battery science, then I think that could potentially be relevant. And so I think nothing is too fundamental, let's say it that way, likely.
And also regarding scope, what about hybrid LICs?
I don't know enough. There's not enough detail to answer. Craig, do you want to?
I assume it's lithium-ion capacitors. So again, I'll go back to the previous answer that if the storage mechanism it could be considered as chemical storage or formation of chemical bonds, redox, reactivity, Faradic, charge storage, those kinds of things, then it fits within the definition of the FOA. But if it's simply storing energy through an electric field, then that's what I would call a standard capacitor, and that's not included in this FOA.
And another question about potential scope. Are battery technologies that can accommodate expansion of next generation electrodes through actuation reasonably within the scope?
So I think the short answer, as the question is written, which is battery technologies, is that the answer is probably not if it's really about battery technologies. If it's about fundamental science to understand and address issues of expansion, then potentially within scope, if there's basic science to be done to address the materials or chemistry issues related to electrode expansion, as best I understand the question.
Well, many thanks to everyone who's joined us today to talk about this funding opportunity. I'm not seeing any other questions in our chat. Okay, we actually had a few just pop in. So another reminder, as we're coming close to time, please do add your questions to the Q&A box so that we can try to answer them as part of this session. Do you have a specific definition of transformative? Is there a range of minimum improvement in any particular metric that's expected?
So the answer is no, that we don't, and the FOA does not define transformative. And I know that's potentially challenging, but really we want you to make the case to us that this is transformative, that this is really going to enable dramatic improvements potentially. Again, it's all about the foundations, but we're laying the foundations for dramatic improvements in energy storage technologies in the future. And it's a longer term timescale. We're not looking at the next year or two. We're really looking at the science being impactful into the longer term 5 to 10 year beyond future. So no definition of transformative, but we're looking to you as the applicants to make the case to us. And
all right.
I see this last one, Michael. I can try to answer this. Somebody asked
Sure.
about whether that they have a technology that's probably too applied for this FOA, but they're interested in sharing it with us. And so all of our contact info is available. You can find me or Craig or anybody. It's probably the case that you don't want to be talking to us in the basic science part of DOE, but maybe into a more applied offices, and we can help you to try to connect if that would be helpful.
All right, well, once again, thank you very much, Andy, and thanks to the other people who are helping us respond to questions today. Linda, Craig, John, Mike Sarkin. I don't see any other questions in our chat, so I'll just remind all the viewers that we'll have the full video online as a reference. Please look for that. And of course, further questions can be asked through the FedConnect portal. So thank you all very much for joining us today.
Thank you, everyone, and thank you, Michael, for moderating. I appreciate it.